Hi, we're going to do the limit definition of an integral. So basically, what I need to do is write this as the limit as n approaches infinity. The n is the number of rectangles we're going to make underneath the curve. So like the rectangles we're adding to get a Riemann sum. So we're going to take a Riemann sum from k equals 1 to infinity. So like partition 1 to partition infinity, or rectangle 1 to rectangle infinity. And then we're going to take f of x sub k times the change in x. And we're going to break this down. All right, so I have the curve. This is a very rough sketch, but here's the curve of x cubed. And we're going to take the value, the area under the curves from 3 to 7. So we want this area here. Okay, so we're going to split this up into rectangles. This rectangle right here, this x value would be x sub k or x sub 1. It's the first rectangle. Okay, the second rectangle would be at the length of x sub 2, x sub 3, x sub 4, so on and so forth. So the k value is just the name of the rectangle. So are you the first, the second, the third, the fourth rectangle? Okay. The change in x is going to be the total distance. The change in x is the width of the rectangle. So in green here is the change in x. So the way we get the change in x is we take the b value minus the a value over the n, which gives us 7 minus 3 over n. And change in x over the change in x is b minus a over n, because that tells us, like, the total distance. We have our b minus our a divided by the number of rectangles that we're going to split the area up into. Okay, now notice that eventually n is going to equal infinity, so we're really saying that we're going to split the area up into infinity rectangles. So that's how we get basically the integral. Next up is we need to figure out the height of each one of the rectangles. So I'm going to figure out the height of the rectangle by saying that the height is equal to f of x sub k. Okay, so, and k, remember, is where it's the placement of the rectangle. So k is going to be like x sub 1 because that's the first height or the first rectangle, or x sub 2 or x sub 3. So we're going to write a general rule for the height. So to get the x value, we write x sub k is equal to a plus k times the change in x. So in our case, our a value is 3. Okay, so plus k is how many times we're going to add delta x, which is basically, oh wait, I never finished this. This is 4 over n. So times 4 over n. So what we're saying is that we're adding, for k equals 1, we're going to add 3 plus 1 times 4 over n. So it's 3 plus a little bit. Okay, then the next height is going to be like 2k, so you're adding 2 delta x's. 3k would be like 3 delta x's. So it tells you how many delta x's to add to your starting value. Okay, so to get the height, we do f of x plus k is equal to x. Let's remember that f of x is equal to x cubed. So we're going to plug in for x, we're going to plug in 3 plus k, 4k over n. Okay, this part inside is x sub k. So to write the integral as the limit, we do the limit as n approaches infinity of the sum of k equals 1 to infinity of all the heights. This is basically the heights of the rectangle times the width of the rectangle. So the height would be f of x sub k, which is 3 plus 4k over n cubed, times delta x, and delta x would be 4 split into n rectangles. So this is the limit definition of an integral.